So in this unit, the main part of trig that we're going to kind of get into is this changing from a measurement of angle with degrees to using something called a radian measure. Okay, so its radian measure is a different angular measurement. So one of the things that the easiest way to look at radian measure really is just kind of difference between radians and degrees would be like centimeters and inches. So in general, we say that there are 2.54 centimeters per 1 inch. And we're really measuring the same thing. Okay, now radians are slightly different, but in the simplest terms, this is kind of how we look at it. Okay, so we can use a conversion factor of 1 radian is about 57.3 degrees about. Okay, so that is kind of an equivalent to saying, okay, well, radians is our inches, degrees is our centimeters. Okay, now that's kind of a simplified way of looking at it, but it's a practical way and it's an easy way to just kind of do easy conversions between radians and degrees. Okay, I'll give you a much more concise one in a little bit, but we should really have a little bit deeper understanding of what a radian is. Okay, radians are really, it's basically it's using an arc length to measure a rotational turn. So that angle here can be related to how far we've turned around the circle. Okay, and we can measure that with an arc. And the reason why we would do this, and this is why we always use radians in calculus, is degrees is not a length measurement. Okay, degrees is kind of a measurement of how much you turn, and that's really incompatible with all our other measurements of length. Okay, we do all our geometry with length of things, right? We need to know how long something is. Whereas an angular turn isn't really telling us how long something is. So what we want to do then is the radian actually is a way to measure a length on the circumference. Okay, now the way we've established a radian is to do this, is that if we have a unit circle, a circle with radius 1, the arc length represents the number of radians that we turn. Okay, so if we think of a circle with radius 1, okay, so I have a radius 1 centimeter circle, the distance all the way around would be 1 circumference of that radius 1 circle, which is 2 pi. Okay, and we can say that halfway around the circle is 1 pi, and we can say that a quarter circle is half a pi, and we can say that 3/4 of a circle is 3/2 pi. And we start talking about the turn as how far along that arc we're using. Okay, and the reason why that's useful is because now we're talking about the length. Now that length changes depending on the size of the circle, but at least now we're talking about the length of that circle. When we say 1 radian, we're talking about 1 unit of length along that circle, along that circumference. Okay, so 1 radian is just 1 unit of length here, so about 1 centimeter, and that radius is about the same as that length, and that works out to be about 57 degrees. Okay, so that's a little bit more deeper looking at radians, but for now, again, like I said, we can probably get away with just saying that it's a conversion. Okay? A radian is 180, or sorry, pi radians is 180 degrees, so that's our conversion factor. Okay? Pi to 180 degrees, and that makes this, if we want to make this a unit ratio, it's about 1 to 57.3 degrees. Okay? So this is our reference that we're going to start using. We're going to start using radians, and to work out the radian measurements, we do it in terms of pi, because a pi lets us break up the fractions of a circle in much nicer pieces. Okay, so again, why are radians used? Well, it's allowing to relate a central angle to the circumference. So we're talking about relating a turn to now a length. Okay? And that is very important for us to be able to do calculations later on.